Welcome to section 7.2. This is the first video for chapter 7, but that's okay as well. But what section 7.2 deals with is the parabola. And this should be very straightforward relatively. There might be some new things that we're talking about, but realize it will all come out in the end. Now we start out with trying to figure out what is the graph, or what does the graph look like when we have an equation such as x squared equals 6y. Now we'd like to see it in this form where we have something squared and all the rest to the other side for a parabola. And it might be some, this could be x plus 2, the quantity squared, or something like that. But realize that whenever the x is squared, that means the parabola will either go up like that, or it will go down like this. Now, if y is squared, then that means it's either going to be going from the right or from the left. And so the only other thing that really matters is whether or not the the value here is positive or negative. So x squared says it's either going to be looking up like that or down like that. Since we have a positive number, we know it's going to look like this, more or less. And the only one that one fits is B. Now number 2, on a parabola we have to realize we have some points. And I'm going to actually redraw this a little bit closer and use this as my notes. We get a point here, and we get another line along here. Now this point here is called the focus, and it does have a huge part in how the parabola is made. But what we have to realize is this distance right here is the distance called P. And this is true whether it is at the origin or not. The distance between the vertex, which is right here, the vertex and the focus is always P. Now that includes if it's y squared over here, then there's a vertex and there's a focus, and that distance will be P. Now it just so happens that the exact same distance is right here, P, and that goes to this line, which is called the directrix. Now the directrix plays a big part in how the parabola is formed as well. I'm not going to spend the time to do that, but realize that if we would take a string here, or the distance from the focus to a point out here, will always be equal to the point there to the directrix. And that's how a parabola is defined. So now what we have for number 2, we're told the focus is at 4, 0, and the vertex is at 0, 0. Now it doesn't look anything like this, because if we would just draw a very rough sketch, that means the focus is here, and the parabola wraps around the focus. And so we get this information. But the question is, what is the equation of the parabola? Well, first of all, since it's going this way, we know it's y squared. So what we get is y squared equals, and then this is, we use 4px. Now if it were an x squared, it would be x squared equals 4py. But in this case, we need to wrap it around this way. So it'll be y squared equals 4px. But in this case, if the focus is here at 4, 0 and the vertex is at 0, 0, p would be the distance from here to here, or 4. So this becomes 4 times 4x, or 16x. So the graph, or the equation of this parabola, is y squared equals 16x. Example number 3. We are asked to graph the equation x squared equals 12y. And there are the things that I want to look at. First of all, what is this going to look like? Well, it's positive and it's x squared. So that means it's going to go up like that. So that's the first thing I'm going to look at. Now, in particular, I need to get a value for p. Well, we know that p, it's 4py. Well, in this case, we have the x squared, and 4p is now going to have to equal 12. So the way that happens is 4 times 3y. So x squared equals 4 times 3y. This 4 is just the standard number that needs to go along with it. So that tells us p is equal to 3. So now let's see what that's going to cause us to do. First of all, the vertex is at 0, 0. There are no expressions here like x, x plus 5 or y minus 1 or anything like that. So that means the vertex is at 0, 0. This plays into when we did transformations. Same type of rules apply. Then we want to find the focus. Well, the focus, we have to realize if the vertex is here, the focus would be about here, and the distance there is 3. So if the focus is 0, 0, then that would be the point 0, 3. And the directrix is the line that goes along here. Okay, so since it's a horizontal line, we know it's y equals. And how far away is it? Well, it's exactly the same distance. So if this is 0, 0, then this would be down here when y is equal to -3. So there's the directrix. So when we actually graph this, all we need to do is figure out, okay, the vertex goes there, the directrix is here at y equals -3. The focus will be here at 3, 0, and then we draw the parabola going around it, like that. Okay, so that's how we get the graph of that particular equation. So with that in mind, let's take a look at number 4. Now number 4, we throw in a whole bunch of stuff right off the bat. X minus 2, the quantity squared, equals 7 times y plus 1. Okay, a couple things. First of all, these will change the vertex in in a way that is similar to the transformations that we've dealt with. But the first thing we have to do is to get this into the normal parabola form, which is 4 times something, 4p here. So in other words, we need to figure out 4p has to be 7. So that means p will equal 7/4. So we get x minus 2, the quantity squared, equals 4 times 7/4 of y plus 1. Now, what this plays a part, this helps us to figure out how fat the parabolas are or how skinny they are. If the focus is 1, it would be what you might consider your standard fatness of your parabola. And the bigger it gets, the fatter it gets. Okay, that's a good rule of thumb. So what we look at number 4 is, first of all, we want to find the vertex. Well, the vertex is, okay, x, we're going to move 2 places. It's always x minus whatever the x value is, y minus the y value. So the vertex is x equals 2, and the y value would be -1, because we always take the opposite, or we always do x minus the x value, y minus the y value. So the vertex is 2, -1. We have to understand that it is going to look like this. It's going to go up because the x is being squared. So we've got that. We have the vertex is equal to 2, -1. The focus, well, we know that the focus is, or p is 7/4. So if we're over here at 2, -1, at the vertex, the focus is going to be up by 7/4, which puts us about right there, or the point 2 3/4. And the directrix would have y equals, okay, we're coming along here. Let's see, we're here at -1, but we have to go 7/4 down further. So that would be at -11/4. And so the question becomes, which one does that fit? Well, A and C are thrown out because the vertex is in the wrong place. The problem is, which one is it, B or D? Now, if the focus was 1, then what we'd probably get is something that looks like this. And 2, you know, would be out here, and even bigger would just keep on getting progressively fatter very quickly. And so between these, we have B or D. It actually ends up being B. Now, if all else fails, look at the intercept. In other words, where does x, or when x equals 0. When x equals 0, this would equal 4, and 4 would equal 7y plus 1. And quickly solve that, you would see that it would be negative wherever it's at versus the -1 on D. So the correct answer here is B. Now 5 asks us to find the equation, and a rough sketch will certainly help. Number 5, the vertex is 7, -5, and the focus is 7, -2. So let's just draw this real quick. 7, -5 will be here. 7, -2 will be the focus, so that's here. So if this is the vertex and this is the focus, it has to wrap around it, so it's going to look like that. So that tells me I know it needs to be x squared. Now, in particular, it's going to be x minus the x value. Well, the x value of the vertex is 7. So x minus 7, quantity squared, equals 4 times, okay, p. We need to calculate p. That's that distance between the focus and the vertex. And that has a distance of 3. So I'm going to put in 4 times 3 times, now I need the y values. Y minus the y value. Well, the y value of the vertex is -5, so that becomes y plus 5. And so just cleaning this up, this becomes x minus 7, the quantity squared, equals 12 times y plus 5. And we're just going to keep it this way because this tells us a whole bunch of information. So there's the equation for number 5. Next we get to example number 6. Example number 6, we have x plus 3, the quantity squared, equals 16 times y minus 1. And we need to find the vertex, the focus, and the directrix. So we need the vertex, the focus, and the directrix. I'm going to do a quick sketch. X squared, so that means it's either going to be up or down. The vertex is at -3, 1. So that's where the vertex is going to be. And I know it's either going to go up or down. Since this is positive, it goes up. So it's going to be like that. So that means my focus is going to have to go there. So first of all, the focus, or the vertex, was pretty easy. -3, 1. The focus has to go up p from there. Well, we have to determine what p is. P is determined through here. It's not 16, but we do know that 4p equals 16, or p equals 4. So what I have to do is I have to move up 4, and so my focus would be -3, 5. Directrix goes along like this. Y equals what? Well, I have to go the exact same distance, p, which is 4. 4 below the vertex would be at -3. So y equals -3 would be the directrix. Number 7 asks us to find all those things and then graph it as a result. So here we've got a little bit of a different situation. X squared minus 8x equals 4y minus 28. Now, the very first thing we have to do is we have to complete the square. On the squared side. So, remembering how to complete the square, that is, take half of this right here, which is 4, and square it, and we get 16. But to keep things equal, we have to do that over here as well. We have to add 16 over here. So then this becomes x minus 4, the quantity squared, equals 4y minus 12. But now we need to get this thing inside parentheses, factoring out everything that we need, because it needs to be y plus something or y minus something. So we get the quantity x minus 4 quantity squared equals, I'm going to factor out a 4 and get y minus 3. Now we've basically done all the hard part. We realize this is equal to 4p. 4p equals 4, so that means p will equal 1. So that will help. We need to find the vertex, we need to find the focus, and we need to find the directrix. Okay, first of all, x squared, and it's positive, so that means it's going to be going up. So we know it's going up. The vertex will be at 4, 3, because I take the x minus the x value, y minus the y value. So the vertex is 4, 3. So actually it should have been over here, but that's okay. There's my vertex 4, 3. The focus is going to be 1 above that. So if this is 4, 3, 1 above that would be 4, 4. The directrix will be the horizontal line 1 below it. So that will become y equals 2. And then we're asked to actually graph this. So then we would come here, we would find 4, 3. 4, 4 would be the focus. The directrix would be y equals 2. And then we just draw the parabola up like that. And so there would be the graph for number 7. Number 8 asks us to graph, and we're going to go through the exact same process. We have 8 is x plus 1, the quantity squared, equals 7 times y plus 2. Okay, first thing, I'm going to find p. I know that 4p is equal to 7, so p will equal 7/4. And we'll have to deal with that, but that's okay. I need the vertex, I need the focus, I need the directrix, and then I'll be able to graph everything. I realize that x squared tells me it's going to be opening either up or down. This tells me I'm going to be opening up. And so, the first thing, vertex, x minus a negative 1, y minus a negative 2. So my vertex is at negative 1, negative 2. There's my vertex. I know it's going to be coming up like this, so my focus has to go up. My focus is going to go up 7/4. Well, going up 7/4 from negative 1, negative 2 will be negative 1, negative 3/4, or negative 1/4, I'm sorry. So that will put my focus right there. My directrix, I have to move down 7/4 from negative 1, negative 2. So that will become negative, negative 15/4, which is almost negative 4, almost. And then just wrap the parabola around. And so that's what number 8, the graph would look like. But I do want to see all this information so that you have shown me, yeah, this is what needs to happen. Example number 9 and 10 are word problems. And realize these are very, very common types of problems that we may run into. A bridge is built in the shape of a parabolic arch. Okay, so we know it's going to be looking like this because that's the support. And the bridge will be there. The bridge arch has a span of 160 feet. So this whole distance is 160 feet. And a maximum height of 30. So it's from there to there will be 30 feet. Find the height of the arch at 10 feet from its center. So in other words, 10 feet away here. Now, how are we going to do this? Well, I would put this into, put the top of the arch right there at our origin. And knowing what we do know, since it's 160, this is right up at the top, so this would have the point 80, and we know that since it goes down 30, it would be 80, negative 30. Likewise, this would be the point negative 80, negative 30, and this would be the point 0, 0. And so what we need to do is we need to determine, what's going on here. Well, this is an x squared form, so it's going to be x squared equals 4 py. Now, what we have to do from this point is we have to plug in some values that we know, say 80, negative 30. So if I plug in 80 in for x, I get 6,400 equals 4 p times the negative 30. Okay, 4p times negative 30 is negative 120p. And then if we divide both sides by negative 120, then p becomes negative 160 over 3 when it's all simplified. Negative 160 over 3. So our equation now becomes x squared, because I've centered it, that makes my life a whole lot easier. X squared equals 4 times p, negative 160 thirds, y. And so now how I need to figure out, okay, what is my y value when x is 10, because I'm asking when I'm 10 feet from the center. So all I have to do is plug in 10 in for x and solve for y. So 10 squared equals, okay, that would be negative 640 over 3 y, and then divide both sides by negative 640 thirds, and 10 squared of course is 100, so y would equal negative 5/12 when this is all said and done. Negative 5/12. So we've got y equaling negative 5/12. That would represent this distance right here. So let's see what the question is. Find the height of the arch. Well, the height of the arch would be from here to here at that point. So at that point, I know from the axis down to here is 30, so I need to take out the 5/12 that is there. So that would be 30 minus the 5/12 that we fell short, and this is equal to 355/12 feet. 355 over 12 feet. Number 10. Okay, we have, it's a parabolic arch, and we have a bridge, and we hang a wire that is going to hang like this, and it ends up looking much, or it is, a parabola. In one section, cable runs from the top of one tower down to the roadway, just touching it there. So here's the roadway. And then it goes back up to the tower again. So to make my life easier, I'm going to put the vertex right there. Now the towers are 50 inches apart. So if this is 50 inches apart, then that means 25 here, 25 here. So that's pretty simple. And at a point between the towers, and 17.5 inches along the road from the base of one tower. So we're talking 17.5 here. The cable is 0.56 inches above. So right there, so this point right here would be the point, well, let's calculate it quickly. If it's 17.5 here, and it's 25 all the way, so this would be a negative, what, negative 7.5 for the x, and the y value would be 0.56. So that point is on the graph, as is a few others. Such as we know the point here would be negative 25. X. That's what we're trying to find. We're trying to find the height of the towers. That's what's being asked. So first thing we need to do is realize this is an x squared equals 4py. And what we need to do is at negative 7.5, or this would also work for 7.5, so it doesn't really matter. Negative 7.5 quantity squared equals 4p times 0.56, because that's the y value. And then we need to solve for p. That's the first thing we need to do, is figure out what does p equal. So this will become, okay, 56.25 equals 2.24p. Divide both sides by 2.24, and p equals 25.112. So that's what p is. So now we can plug that in back into the formula. X squared equals 4 times p times y. And we know that we're trying to find, this shouldn't be an x, this should be a y. We know that we want to find out what is the y value right here. Well, that's when x is equal to 25. So 25 squared equals, okay, 4 times that is 100.446, or 448, I'm sorry. Y, 25 squared is 625, so y will equal 625 divided by 100.448, which is equal to approximately 6.22 inches. And that is how high our towers would be, 6.22 inches, if everything else is